Welcome to Hartman Math. This is lesson 4.6 where we're going to be graphing square root functions. So we're going to start with our parent function, f of x equals the square root of x. This becomes our base graph. Whenever we graph new functions, we like to do a table of values. So we've got our x's, we've got our f of x or y values in terms of coordinates. So normally we pick some positives, we pick some negatives, we see what's going to happen. It's a little bit different with our square root function, being that in the real number system, we're not allowed to take the square root of negative numbers. We really don't want to pick negative numbers. We're going to pick non-negative numbers. But we also want to pick, to have nice points, numbers that we can easily take the square root of. And you might think, well, like 4. 4 is a good one. We could take the square root of 4. So if we substitute that in, the square root of 4 is 2. We would have a point at 4 comma 2. What else? 0 is a good one. 0, the square root of 0 is 0. Point. What else can we take? Easily take the square root of? 1. The square root of 1 is 1. A point. I wouldn't want to pick 2 because if I square root 2, that's hard to figure out where the value is. I can try it on a calculator and approximate it. It's about 1.4, but I want to pick nice integer values. So that's why the next x value we would pick is 4. If we had a larger graph, maybe we pick 9. The square root of 9 is 3. So 9 comma 3 is a point. I don't think that one fits, but 4 comma 2 does. Here's our 4 comma 2. And as far as the graph goes, since we can't pick negative numbers, we don't want any values over here. So we have this point here, 0 comma 0. We're going to call it an initial point. It starts here and then goes that way. So notice that it doesn't go down, it doesn't have an arrow, it doesn't go anywhere else. It has this initial or starting point and then goes to the right or up, depending on how you want to look at that. And that would be our parent function. So let's take a look at some of the key characteristics of our square root function, such as domain. How far left and right does it go? Well, left and right, it starts here at 0. At 0, there's a point there. So bracket 0, comma, goes right forever. Bracket 0, comma, positive, infinity, parenthesis. What about range? How low does it go? 0. It touches 0. It goes up forever. Arrow pointing up. Mostly right, but it keeps going up. So range is from bracket 0, comma, positive, infinity, parenthesis. Where is it increasing? Where is it going up? Well, it's going up throughout its domain. But we always use open intervals for increasing, decreasing, and constant. So we'd say after 0, it's going up. So parentheses 0, comma, positive, infinity. Where is it decreasing? Where is it going down? Well, it's not. So that's a none. And it's not horizontal anywhere, so that's a none. What about x-intercept? Where does it touch or cross the x-axis? Well, it touches right here at 0, comma, 0. And that's also on the y-axis. So the y-intercept, same point, 0, comma, 0. What is the interval where our function is positive? Where are we above? Well, not at 0, because we're on. It needs to be above. So anything past 0, so this would be from 0 to infinity. We're talking about x coordinates domain interval. Where is it below the x-axis? It's not. And then as far as end behavior, because we had an initial point and don't go left forever, we're only going to look at this as a one-sided end behavior. So it wouldn't make sense to look at as x goes to negative infinity because it doesn't go to negative infinity. So we're going to say as x approaches positive infinity, the function keeps going up and up and up towards positive infinity. So now that we've got an idea what the parent function looks like, can we graph a function where this is the general form of our square root function with a, which does the same thing it's done to all the other functions that we've looked at. If a is negative, it's going to flip it across the x-axis. If a is a large number, it's going to stretch it vertically. If it's between 0 and 1, it's going to compress it. And we've got our h and k that do our shifting horizontal and vertical. That's going to affect our initial point, because our initial point is the h comma k. So that's probably a good place to start for our graph, is the initial point. H is 2, x minus 2. Inside parentheses, or in this case, underneath the root, think opposite, 2 comma negative 3. So we'll start out there at 2 comma negative 3. And then the a value is 1, so we just have the exact same shape as our parent function, which was from there, right 1 up 1. And then we kind of want to think back to Unit 2 where we're doing pattern of the odds, but this time we're going horizontal. Second odd number is 3, up 1 again. And there's our other point. Our third key point, we're going to need 3 key points. Initial point, have it going to the right, there is an arrow there. All right. Then things that we might be asked about would be the one-sided end behavior. As x approaches infinity, f of x is, or g of x is approaching, going up, that's positive infinity. X-intercept, y-intercept. So to find x-intercepts, set the function equal to 0. And solve. So back in 4.4, we were looking at solving radical equations. Use those techniques. We're going to isolate. We're going to undo the minus 3. We'll add 3 to both sides. We'll do the inverse of square root. So we will square both sides. When I square the right, it just cancels out the root. I get x minus 2 equals 3 squared. 3 squared is 9. Add 2 to both sides. 9 plus 2 is 11. It's not showing on the graph, but we will hit the x-axis at 11, 0. The y-intercept should be easier. Just substitute in 0 for the x. 0 minus 2 is negative 2. Square root negative 2. Try that on a calculator. It's going to give you an error message, because in the real number system, we're not allowed to take the square root of negative numbers. If you kind of take a look, our graph never touches the y-axis, so both of those confirm there is no y-intercept. Example number 2, let's graph h of x. H of x is equal to negative 2 times the square root of x plus 6. Let's start with the initial point. What is it? H coming from here is 0, comma 6, right up there. And then the pattern would be right 1 up 1, except here's our a value of negative 2. So instead of going right 1 up 1, let's multiply that up 1 by negative 2. So we're going to actually go right 1 down 2. Then again, pattern of the odds, right 3. And instead of going down 1 again, we're now going down 2 again. So the vertical change is always going to be the same on our square root graphs, and that's going to be based off of the a. So if a was negative 5, we'd be going down 5 each time as we go right 1, right 3. Got enough points? Don't go this way. Start here, only go one direction. So in terms of end behavior, if it said as x approaches positive infinity, what does h of x approach? It keeps going down and down forever. That would be negative infinity. So to find the x-intercept, we'll just set the whole function equal to 0. And then we could subtract 6 on both sides, or we can undo the negative 2 root x by just adding that to both sides. I kind of prefer positive, so we could do that. Either way, after one more step, if you had subtracted 6 from both sides, we'd be at the same spot anyway. So we still want to isolate, so let's get rid of this 2. We're going to divide both sides by the 2. And then to undo the square root, we'll do the inverse function. We will square both sides. So we get x equals 3 squared. That's 9. So our x-intercept is 9, 0. The y-intercept, well, we do see it. If we wanted to go through the process of plugging in 0, h of 0 equals, the square root of 0 is 0, times negative 2 is still 0, plus 6, we do get a y-intercept, and we see it here on the graph of 0, 6. All right, it's now your turn. You're going to graph w of x. Pause the video here as you work through. Get the graph, initial point, x-intercept, and y-intercept. Play when you're ready. All right, so our initial point is negative 2, 3. We will start there. And then our a value is 1/2, so we will go right 1 up 1/2. And then right 3 up 1/2. And we can draw the graph from there. All right, the x-intercept, kind of look at the graph. But for our procedure, if we want to go through that, 0, set the function equals 0, 0 equals, and probably a good idea to subtract 3 on both sides. How would we get rid of the 1/2? Maybe think reciprocal on that, multiply both sides by 2, that'll cancel that out. We would get negative 6 is equal to the square root of x plus 2. But I think that creates an issue for us. Because when we take the square root of a number, anytime you do that on your calculator, you can't get a negative number. The square root of any real number is going to be non-negative. It could be 0, it could be positive. It's never going to be negative. So no x is going to lead us to a true solution. And we see that we're not going to touch the x-axis. So that would be none. And the y-intercept, it's not a real nice point. So let's kind of go through and see what substituting in a 0 is. W of 0 is equal to 1/2 square root 0 plus 2. That's 2. So the square root of 2 times 1 over 2, add 3. That becomes our y-intercept as an exact value. Square root of 2 divided by 2, add 3 is our exact value for our y-intercept. That's it for today. I'll see you next time.